Hello everyone and welcome to this amazing video on Kubernetes. You're watching your very own Simplilearn YouTube channel, so make sure to subscribe to our YouTube channel and like this video. In this comprehensive Kubernetes tutorial, we will discuss the entire process of how Kubernetes automates operational tasks of container management. We will understand containers right from scratch and move on to more advanced topics covering each and every step with detailed hands-on demonstration. This tutorial will ensure that you get an exhaustive understanding of Kubernetes, its architecture, and how to use Kubernetes for container management. With that being said, make sure to comment your opinion on this video and subscribe to us to never miss any of the amazing tech content we bring just for you. Let's get started. Just a quick info for you. If you want to upskill yourself, master DevOps skills, and land your dream job or grow in your career, then you must explore Simplilearn's cohort of various DevOps programs. Simplilearn offers various certification and postgraduate programs in collaboration with some of the world's leading universities like Caltech and Google Cloud. Through our courses, you will gain knowledge and work-ready expertise in skills like DevOps methodology, deployment automation, CI/CD pipeline, and over a dozen others. That's not all. You will also get the opportunity to work on multiple projects and learn from industry experts working in top-tier product companies and academians from top universities. After completing these courses, thousands of learners have transitioned into DevOps role as a fresher or moved on to a higher paying job role and profile. So if you are passionate about making your career in this field, then make sure to check out the link in the pinned comments and description box to find DevOps program that fits your expertise and areas of interest.
Hello and welcome to Simplilearn. In this session, we're going to cover what Kubernetes is and why you would want to be using it within your DevOps team. But before we get started, remember to hit the like button if you like this video and the subscribe button if you want to get notified about more of these videos as they come out. And as always, if you have any comments about the content that we're covering or questions that you have on the subject, please post them in the comments below. So let's get started. We're going to break up this presentation into 4 key areas. We're going to talk about life before Kubernetes, which some of you are probably experiencing right now. What is Kubernetes? The benefits that Kubernetes brings to you, particularly if you are using containers in a DevOps environment. And then finally, we're going to break down the architecture and working infrastructure for Kubernetes so you understand what's happening and why the actions are happening the way that they are. So let's jump into our first section of life before Kubernetes. So the way that you have done work in the past, or you may be doing work right now, is really building out and deploying solutions into 2 distinct areas. One is a traditional deployment where you're pushing out code to physical servers in a data center, and you're managing the operating system and the code that's actually running on each of those servers. Another environment that you may potentially be using is deploying code out to virtual machines. So let's go through and look at the 2 different types of deployment that you may be experiencing. When you have applications running on multiple machines, you run into the potential risk that the setup and configuration of each of those machines isn't going to be consistent and your code isn't going to work effectively, and there may be issues with uptime and errors within the infrastructure of your entire environment. There's going to be problems with resource allocation, and you're going to have issues where applications may be running effectively and not effectively and not load balanced effectively across the environment. The problem that you have with this kind of infrastructure is that it gets very expensive. You can only install one piece of software or one service on one piece of hardware, so your hardware is being massively underutilized. This is where virtual machines have become really popular. With a virtual machine, you're able to have better resource utilization and scalability at much less cost. And this allows you to be able to run multiple virtual machines on a single piece of hardware. The problem is that VMs, or for virtual machines, are not perfect either. Some of the challenges you run with VMs is that the actual hardware and software needed to manage the VM environment can be expensive. There are security risks with VMs. There are security risks with VMs. There have been data breaches recorded about solutions that run in virtualized environments. You also run into an issue of availability, and this is largely because you can only have a finite number of virtual machines running on a piece of hardware. And this results in limitations and restrictions in the types of environment you want to be running. And then finally, setting up and managing a virtualized environment is time consuming. It can take a lot of time and it can also get very expensive. So how about Kubernetes? Well, Kubernetes is a tool that allows you to manage containerized deployment of solutions. And inherently, Kubernetes is a tool that is really a next level maturity of deployment. So if you can think of your maturity curve as deploying code directly to hardware in a data center, and then deploying your solutions to virtual machines, the next evolution of that deployment is to use containers and Kubernetes. So let's kind of go through and look at the differences between a virtual machine and Kubernetes. And we've got a few here that we want to highlight, and you'll get an understanding of what the differences are between the two. So first of all, with virtual machines, there is inherently security risks. And what you'll find as we dig through the architecture later in the presentation is that Kubernetes is inherently secure. And this is largely because of the legacy code, the legacy of Kubernetes and where it came from. And we'll talk about that in just a moment. But Kubernetes is inherently secure. Virtual machines are not easily portable. Now, with that said, they are technically portable. They're just not very easily portable. Whereas with Kubernetes, it's working with Docker container solutions. It is extremely portable. That means that you can actually spin up and spin down and manage your infrastructure exactly the way that you want it to be managed and scale it on the demands of the customers as they're coming in to use the solution. From a time-consuming point of view, Kubernetes is much less time-consuming than with a virtual machine. A few other areas that we want to kind of highlight from differences. Virtual machines use much less isolation when building out the encapsulated environment than Kubernetes does. For instance, with a virtual machine, you have to run hypervisor on top of the OS and hardware, and then inside of the virtual machine, you also have to have the operating system as well. Whereas in contrast, on a Kubernetes environment, because it's leveraging Docker container or container-like technologies, it only has to have the OS and the hardware, and then inside of each container, it doesn't need to have that additional OS layer. It's able to inherit what it needs to be able to run the application. This makes the whole solution much more flexible and allows you to run many more containers on a piece of hardware than versus running virtual machines on a single piece of hardware. So as we highlighted here, VMs are not as portable as Kubernetes, and Kubernetes is portable directly related to the use of containerization. And because Kubernetes is built on top of containers, it is much less time consuming because you can actually script and automatically allocate resource to nodes within your Kubernetes environment. This allows the infrastructure to run much more effectively and much more efficiently. So this is why if we look at our evolution of the land of time before Kubernetes, why we are running into a solution where Kubernetes had to come about, because the demand for having more highly scalable solutions that are more efficient was just really a natural evolution of this software deployment model that started with pushing out code to physical hardware and then pushing code out to virtual machines and then needing to have a solution much more sophisticated. Kubernetes would have come about at some point in time. I'm just really glad it came about when it did. So what is Kubernetes? Let's dig into the history of Kubernetes and how it came about. So in essence, Kubernetes is an open source platform that allows you to manage and deploy and maintain groups of containers. And a container is something like Docker. And if you're developing code, you're probably already using Docker today. Consider Kubernetes as the tool that manages multiple Docker environments together. Now, we talk a lot about Docker as a container solution with Kubernetes. The reality is that Kubernetes can actually use other container tools out there, but Docker just simply is the most popular container out there. Both these tools are open source. That's why they're so popular. And they just allow you to be able to have flexibility in being able to scale up your solutions. And they were designed for the post-digital world that we live and exist in today. So a little bit of background, a little bit of trivia around Kubernetes. So Kubernetes was originally a successor to a project at Google, and the original project was Google Borg. Google Borg, it does exactly what Kubernetes does today, but Kubernetes was rewritten from the ground up and then released as an open source project in 2014 so that people outside of Google could take advantage of the power of Kubernetes containerization management tools. And today it is managed by the Cloud Native Computing Foundation. And there are many companies that support and manage Kubernetes. So for instance, if you're signing up for Microsoft Azure, AWS, Google Cloud, all of them will leverage Kubernetes, and it's just become the de facto tool for managing large groups of containers. So let's kind of step through some of the key benefits that you would experience from Kubernetes. So we have 9 key benefits. The first, it is highly portable. It is 100% open source code. And this means that you can actually go ahead and contribute to this code project if you want to through GitHub. The ability to scale up the solution is incredible. What's the history of Kubernetes being part of a Google project for managing the Google network and infrastructure kind of really sets the groundwork for having a solution that is highly scalable. Out of the high scalability also comes the need for high availability. And this is the desire to be able to have a highly efficient and highly energized environment that also you can really rely on. So if you're building out a Kubernetes management environment, you know that it's going to be available for the solutions that you're maintaining. And it's really designed for deployment. So you can script out the environment and actually have it as part of your DevOps model so you can scale up and meet the demands of your customer. Then what you'll find is that the load balancing is extremely efficient, and it allows you to distribute the load efficiently across your entire network so your network remains stable. And then also the tool allows you to manage the orchestration of your storage. So you can have local storage such as an SSD on the hardware that the Kubernetes is maintaining. Or if the Kubernetes environment is pulling storage from a public cloud such as Azure or AWS, you can actually go ahead and make that available to your entire system. And you can inherit the security that goes back and forth between the cloud environments. And one of the things you'll find consistent with Kubernetes is that it is designed for a cloud-first environment. Kubernetes as well is that it's really a self-healing environment. So if something happens or something fails, Kubernetes will detect that failure and then either restart the process, kill the process, or replace it. And then because of that, you also have automated rollouts and rollbacks in case you need to be able to manage the state of the environment. And then finally, you have automatic bin packaging, so you can actually specify the compute power that's being used from the CPU and RAM for each container. So let's dig into the final area, which is the actual Kubernetes architecture. And we're going to cover this at a high level. There's actually another video that you can that Simplilearn has developed, which digs deeper into the Kubernetes architecture. And so the Kubernetes architecture is a cluster-based architecture, and it's really about 2 key areas. You have the Kubernetes master, which actually controls all of the activities within your entire Kubernetes infrastructure. And then you have nodes that actually are running on Linux machines that are controlled by the master. So let's kind of go through some of these areas. So if we look at the Kubernetes master to begin with, we'll start with etc. This is a tool that allows for the configuration of information and the management of nodes within your cluster. And one of the key features that you'll find with all of the tools that are managed within either the master environment or within a node is that they are all accessible via the API server. And what's interesting about the API server is that it's a RESTful based infrastructure, which means that you can actually secure each connection with SSL and other security models to ensure that your entire infrastructure and the communication going back and forth across your infrastructure is tightly secured. Scheduler goes ahead and actually, as you'd expect, it actually manages the schedule of activities within the actual cluster. And then you have the controller, and the controller is a daemon server that actually manages and pushes out the instructions to all of your nodes. So the other tools really are the infrastructure, and you can consider them the administration side of the master, whereas controller is the management. It actually pushes out all of the controls via the API server. So let's actually dig into one of the actual nodes themselves. And there are three key areas of the nodes. One is the Docker environment, which actually helps and manage and maintain the container that's actually inside of the node. And then you have the kubelet, which is responsible for information that goes back and forth, and it's going to do most of the conversation with the API server on the actual health of that node. And then you have the actual Kubernetes proxy, which actually runs the services actually inside of the node. So as you see, all of these infrastructures are extremely lightweight and designed to be very efficient and very available for your infrastructure. And so here's a quick recap of the different tools that are available. And it really breaks down into two key areas. You have your Kubernetes master and the Kubernetes node. The Kubernetes master has the instructions of what's going to happen within your Kubernetes infrastructure. And then it's going to push out those instructions to an indefinite number of nodes that will allow you to be able to scale up and scale down your solution in a dynamic way.
Hi guys, in today's video I am going to show you how to install Ubuntu on Kubernetes. Kubernetes is an open source platform used for deployment and management of containers. So let's get started. Now the first step is to install the necessary dependencies using two of the commands. First is sudo apt get update, which gets all the updates, and then you have to enter a password. So this will take a few seconds. That's done. The next step is to install apt transport HTTPS. This is basically used to make repositories via HTTPS. So let's go ahead with that. Sudo. Okay, that's done. Going ahead, the next thing we have to do is to install the Docker dependency using the command sudo apt install docker.io. You have to choose Y, and this will take a few minutes. Okay, that's done. So after installing the Docker, we have to start and enable the Docker using the command sudo systemctl start docker and sudo systemctl enable docker. So now the Docker is enabled. So now we are done with the first step of installation. The next step is we have to install the necessary components for Kubernetes. Before that, we have to install the curl command because curl command is used to send data using a URL syntax. Let's install the curl command using the command sudo apt get install curl. So you have to select Y, and this will take a few minutes. So moving on, the next step we have to do is download and add key for Kubernetes installation from a URL. So let's go ahead with that. Sudo curl. So this is where we get the key, and then we have to add it using sudo apt key add. And it's done. So the next step is we have to add a repository in a certain location. So before doing that, we have to change the permission of that file. So we do that using sudo chmod command. Okay, so the permission is changed. Now, let's go ahead and save this file in that location. First, we have to enter this command into the file. This is a URL. Save as. So we have to save it in this location. Let's rename this to Kubernetes.list. Now let's see. Okay, so here it is. Now, moving forward. Now we have to check for any updates available. In the next command, we are going to install the Kubernetes components. That is kubelet, kubeadm, kubectl, and Kubernetes CNI. So let's go ahead with that. So this is going to take a few minutes. Now that's done. So the next step, we have to initialize the master node, and to do this we have to first use a swap off command to disable the swapping on other devices. So let's do that, sudo swap off -a. Now let's go ahead with the initialization, sudo kubeadm init. This is going to take a few minutes. Okay, so before going to the next step, to start the cluster we have to use these three commands. Let's just copy paste it. Okay, that's done. So moving forward, the next step is to deploy pods using the following command. Now the pods have been deployed to our network. To see all the pods, you have to use the command sudo kubectl get pods. There you can see the pods that have been deployed.
Hello, and in this video we're going to cover a common conversation, which is Kubernetes versus Docker. But before we jump into that, I want you to hit the subscribe button so you get notified about new content as it gets made available. And if you hit the notification button, that notification will then pop up on your desktop as a video is published from Simplilearn. In addition, if you have any questions on the topic, please post them in the comments below. We read them and we do reply to them as often as we can. So with that said, let's jump into Kubernetes versus Docker. So let's go through a couple of scenarios. Let's do one for Kubernetes and then one for Docker. And we can actually go through and understand what the problems specific companies have actually had and how they're able to use the two different tools to solve them. So our first one is with Bose. And Bose had a large catalog of products that kept growing and their infrastructure had to change. So the way that they looked at that was actually establishing two primary goals to be able to allow their product groups to be able to more easily catch up to the scale of their business. So after going through a number of solutions, they ended up coming up with a solution of having Kubernetes running their IoT platform as a service inside of Amazon's AWS cloud service. And what you'll see with both these products is they're very cloud friendly, but here we have Bose and Kubernetes working together with AWS to be able to scale up and meet the demands of their product catalog. And so the result is that we were able to increase the number of non-production deployments significantly by taking the number of services from being large, bulky services down to small microservices, being able to handle as many as 1,250 plus deployments every year. An incredible amount of time and value has been opened through the use of Kubernetes. Now let's have a look at Docker and see what a similar problem that people would have. So the problem is with PayPal, and PayPal processes something in the region of over 200 payments per second across all of their products. And PayPal doesn't just have PayPal, they have Braintree and Venmo. So the challenge that PayPal was really being given is that they had different architectures which resulted in different maintenance cycles and different deployment times and an overall complexity from having a decades-old architecture with PayPal through to a modern architecture with Venmo. Through the use of Docker, PayPal was able to unify the application delivery and be able to centralize the management of all of the containers with one existing group. The net result is that PayPal was able to migrate over 700 applications into Docker Enterprise, which consists of over 200,000 containers. This ultimately opened up a 50% increase in availability for being able to add in additional time for building, testing, and deploying of applications. Just a huge win for PayPal. Now let's dig into Kubernetes and Docker. So Kubernetes is an open source platform, and it's designed for being able to maintain a large number of containers. And what you're going to find is that your argument for Kubernetes versus Docker isn't a real argument. It's Kubernetes and Docker working together. So Kubernetes is able to manage the infrastructure of a containerized environment, and Docker is the number one container management solution. And so with Docker, you're able to automate the deployment of your applications, being able to keep them in a very lightweight environment, and being able to create a nice, consistent experience so that your developers are working in the same containers that are then also pushed out to production. So with Docker, you're able to manage multiple containers running on the same hardware much more efficiently than you are with a VM environment. The productivity around Docker is extremely high. You're able to keep your applications very isolated. The configuration for Docker is really quick and easy. You can be up and running in minutes with Docker once you have it installed and running on your development machine or inside of your DevOps environment. So we look at the deployment between the two and the differences. Kubernetes is really designed for a combination of pods and services in its deployment, whereas with Docker, it's around about deploying services in containers. So the difference here is that Kubernetes is going to manage the entire environment, and then that environment consisting of pods, and inside of a pod, you're going to have all of your containers that you're working on, and those containers are going to control the services that actually power the applications that are being deployed. Kubernetes is by default an auto-scaling solution. It has it turned on and is always available, whereas Docker does not. And that's not surprising, because Docker is a tool for building out solutions, whereas Kubernetes is about managing your infrastructure. Kubernetes is going to run health checks on the liveness and readiness of your entire environment. So not just one container, but tens of thousands of containers. Whereas Docker is going to limit the health check to the services that it's managing within its own containers. Now, I'm not going to kid you, Kubernetes is quite hard to set up. It's of the tools that you're going to be using in your DevOps environment, it's not an easy setup for you to use. And for this reason, you want to really take advantage of the services within Azure and other similar cloud environments where they actually will do the setup for you. Docker, in contrast, is really easy to set up. You can, as I mentioned earlier, you can be up and running in a few minutes. As you would expect, the fault tolerance within Kubernetes is very high. And this is by design, because the architecture of Kubernetes is built on the same architecture that Google uses for managing its entire cloud infrastructure. In contrast, Docker has lower fault tolerance, but that's because it's just managing the services within its own containers. What you'll find is that most public cloud providers will provide support for both Kubernetes and Docker. Here we've highlighted Microsoft Azure because they were very quick to jump on and support Kubernetes. But the reality is that today Google, Amazon, and many other providers are having first level support for Kubernetes. It's just become extremely popular in a very, very short time frame. The companies using both Kubernetes and Docker is vast, and every single day there are more and more companies using it, and you should be able to look and see whether or not you can add your own company to this list. Hello and welcome to Simplilearn. Today we're going to be giving you a Kubernetes tutorial. We'll provide the overview of how and why you should be using Kubernetes. But before we get started, don't forget to hit the subscribe button and the like button if you want to get notified about additional content from Simplilearn. And as always, if you have any comments about the material that you're about to see and you have any questions, please post them in the comments below. We do read them and we do reply to them. So with that said, let's jump in. So we're going to go through a bunch of things today around Kubernetes. We're going to cover what Kubernetes is and why you should be using it, along with the features of Kubernetes. We're also going to take a little bit of a look at Kubernetes versus Docker Swarm, as the two technologies do tend to get referred to quite frequently. And then we're going to do a deep dive into the actual Kubernetes architecture itself and how Kubernetes runs and operates within your network. And then finally, we're going to look at some Kubernetes Kubernetes use cases of how you can actually apply best learnings that other companies have used with Kubernetes. We'll finish everything off with a demo where we actually step through and use some of the actual codes that you can actually use to run from your terminal window to actually activate Kubernetes itself. So with that said, let's jump in. So why Kubernetes? Well, Kubernetes is really being built from allowing you to be able to have a more reliable infrastructure. The tool itself is designed to manage the containers you have within your network. It's very modular in architecture, which allows it to be very easy to be able to maintain and to be able to scale and meet the demands that your current customers are offering you today. The actual ability for you to be able to deploy and update software at scale is really at the heart and center of Kubernetes. It's really one of the reasons why Kubernetes was created, was to be able to scale up the deployment of software to tens of thousands of networks and servers within a data center. And then finally, when you start working with Kubernetes, really what you're doing is laying the foundation for building cloud native applications. And part of this comes from the architecture and history of Kubernetes, which we'll get to in a little bit. But it's good to know that as you're using Kubernetes and containerized solutions, that you're really building out an infrastructure that's designed for cloud-centric solution delivery. So let's dig into what Kubernetes is. So the history of Kubernetes is that it was originally developed by Google. Google actually used the precursor to Kubernetes to manage and maintain the data structure and data infrastructure that they had within their network. They really liked it, and one of the big benefits that Google provided is that they converted their code into an open source program that they released as Kubernetes in 2014 and made it open source. This means that any company can use Kubernetes. There's no charge for it. All you have to do is know how to use the command lines to actually get up and running. The benefit of Kubernetes being open source is that most cloud providers now support Kubernetes. So whether you're using Microsoft Azure, you're using Google Cloud or AWS, you'll find that you can actually use Kubernetes. And Kubernetes at its core really helped eliminate manual processes. So it allowed for deploying and scaling your container-based solutions much more effortless within a cloud environment. So let's jump into the features of Kubernetes and why you'd want to be using it. And we have a number of features that we want to kind of step through. Again, the first thing that Kubernetes is a strong benefit of is that it eliminates those manual processes and allows you to automate them. The benefit you have from this is that you can then scale up your automation across your entire network. So whether you are managing 10 nodes within your network or whether you're managing 10,000, doesn't matter. You have the ability to scale. That's something you simply didn't have before. Kubernetes also will manage the actual containers themselves, including the security, the storage, and the networking within those containers. The great benefit of working with Kubernetes is that not only is it a cloud-centric solution, but it was really built from a core need of a secure solution. So security is at the heart and center of all the work you're doing, which really helps benefit any teams scaling out containers. Your Kubernetes environment will be constantly monitored so that when you have nodes that have your containers, the health of those nodes is being constantly communicated back to the Kubernetes environment so that the entire environment is always being managed and checked. So if you have any additional hosting and launching that needs to be done, Kubernetes will help you automate those manual processes. If something does go wrong, you can actually set up your Kubernetes environment to do an automatic rollback. Again, this is just allowing you to have that confidence that when you're deploying a solution that everything is going to work within that environment. And then finally, Kubernetes will allow you to mount and add the storage needed to run your apps. So whether you have storage such as a local SSD storage device physically on the hardware, or if you're connecting to storage via the cloud, Kubernetes will allow you to access the storage you need, how you're accessing it. So let's look a little bit into the differences between Kubernetes and Docker Swarm. So if we just step back a little bit, Kubernetes and Docker often get connected with each other, largely because Kubernetes manages containers, and Docker is really famous for creating the most popular container management solution, which is called Docker. If you're a developer, you're probably already using Docker today. So one of the things that Kubernetes is really, really good at is that it manages containers at scale, just massive volume of containers. Docker Swarm is Docker's alternative to Kubernetes. It's a tool that allows you to also manage large numbers of containers. There are differences between the two of them, and right now, without doubt, the most popular open source solution out there is Kubernetes from Google. It just has a massive community behind it, and the community really have embraced Kubernetes. Yes, the original product was developed by Google, but Google has been great stewards, and they've allowed the community to drive the future evolution of the product. Docker Swarm is actually managed and developed by Docker. There is a smaller community, but it is also a very passionate community, and the reason being is that both products are actually pretty good, and you just really kind of have to choose which one you want to go with. Without doubt, there is more customization and extensions built for Kubernetes simply because the community is just so much bigger than the Docker Swarm community. But with that said, Docker Swarm is really easy to set up. So if you are used to working within the Docker environment, you'll be able to set up Docker Swarm very, very quickly. Whereas Kubernetes does require some heavy lifting to get up and running. Now, with that said, if you are using Microsoft Azure or Google Cloud, very often those environments will actually set up Kubernetes for you, so you don't have to do it, and you can actually then focus on writing the instructions to maintain your Kubernetes environment. Kubernetes has extremely high fault tolerance. Again, it's because Kubernetes has been road tested. The foundation for Kubernetes is based on managing sites such as Gmail, Google.com, YouTube. I mean, just incredibly robust environment compared to Docker Swarm, which has lower fault tolerance. And this really kind of leads into the final areas where Kubernetes does guarantee strong clusters management, just a really reliable environment. Docker Swarm, however, is able to take containers and deploy them into large clusters very, very quickly. Two interesting differences is that with Kubernetes, the load balancing is still manual, and it'll be interesting to watch how Kubernetes matures that skill set. In contrast, load balancing is automatic within Docker Swarm. So let's dig into the Kubernetes architecture and just kind of expose some of those key elements. If you're interested in actually having a very deep dive into Kubernetes architecture, we have already got another video, and we should have a link in the comments that you can select that will take you to that video as well. But this will provide you an overview as well. So the way that Kubernetes runs is that it uses nodes to actually manage all the individual hardware within a specific unit. And so a node is really a physical machine in a data center or a virtual machine. And when you're setting up an environment on a cloud environment such as Microsoft Azure or Google Cloud or AWS, Kubernetes will be managing the containers within that node. So it's important to know that Kubernetes itself doesn't work with the individual nodes, but actually works with the cluster as a whole. And why that's important is that it's a tool to manage your entire environment. It's not going to come down and manage the individual node itself. It's going to manage the entire environment. The actual control of data within a cluster is very, very flexible within Kubernetes. You can have local storage, such as an SSD card or a traditional local storage, or you can actually connect to the cloud and use cloud-based storage. And the benefit that cloud-based storage offers you is that you are increasingly moving your solution into more of a hardware-free environment, cloud-based architecture, where you're not reliant on a physical piece of hardware within your data center. And why that's important is that it gives you the opportunity to scale up your solutions much more effectively. So if you need to increase the hard drive space, you can do that very easily from the cloud, whereas local hardware is a little bit harder to manage. Great news, Kubernetes gives you both options to be able to choose from. And so the next layer down is the actual management of the application, and that's within a container. And as mentioned earlier, Docker is the most popular container solution out there. And again, if you're a developer, you're probably already using Docker, as it was a natural maturity from using a virtual virtual machine. But Kubernetes itself will actually manage the containers that you have within your nodes. And so you have a collection of containers working together, and then you pull those together into what's called a pod. And what's great is Kubernetes will actually manage the health of that pod. So if a container or a pod fails, Kubernetes will automatically deploy out a replica so your entire environment can stay running and being efficient. And so the pods themselves will actually be managed by Kubernetes. You really want to let Kubernetes do this because it's allowing you to step away from the manual management of pods. Your environment is just going to be healthier relying on Kubernetes to do the actual management of all the pods you have out there. So you are able to allow access to, from services outside of your Kubernetes, and this is done through a process called ingress. And going back earlier, we talked about how security is a key part of all the work that goes into Kubernetes. And this is a great example of where you can use an external service but still have that layer of security that is vital for your solution. Because to be able to provide the ingress connection, Kubernetes requires an SSL connection, which automatically allows for a secure data transfer. Absolutely fantastic. So here we have an overview of the actual architecture. On the right hand side we have our nodes and the pods within our nodes, and within those pods are the containers. On the left hand side we have the master architecture, and the master architecture is the actual brains behind the work that you're doing. It's actually managing the schedules, the controllers for all of the nodes. And then at the bottom left hand side we have commands which are written on a local workstation, and those commands are pushed up to the master. So let's kind of dig a little bit further into the architecture of the master. So the master itself is comprised of a number of key components. Again, this is the tool that's going to manage your entire Kubernetes infrastructure. The key components that you have are the etcd, control manager, scheduler, API server, and the key four components are etcd, or the cluster store, the controller manager, the scheduler, and the API server. The cluster store is the tool where all the details of the work that you're doing is stored. It's going to manage the rules, it's going to manage all the instructions, and this is where you're going to post that information. The controller is actually going to then perform the tasks that are stored in the cluster store. And as you'd expect, the scheduler is the tool that actually controls when instructions and tasks are pushed out to all the pods and nodes within your network. And then finally, you have an API server which allows you to be able to control all the operations. The actual operations themselves are all instructions written as REST instructions, which allows you to take advantage of the security that has been built into REST. And so you end up with a worker-slave architecture, and slaves are all the different nodes and pods within your network. And so a pod itself will have one or more multiple containers, and then each container and then each pod will have a Docker container, a kubelet, and a Kubernetes proxy. And these are tools to allow you to communicate back up to the master layer. So the Docker is the actual container itself, and this is going to actually run your application. And the instructions here are to pull down the correct container from the Docker images that you have within your library. The kubelet is going to manage your containers, and your container instructions that will be deployed to the kubelet are going to be written in either YAML or JSON format. YAML is just great. If you haven't had a chance to start working with YAML, I certainly encourage you to do so. It's very easy to pick up. If you know any XML, you'll pick up YAML very quickly. And finally, the Kubernetes proxy is the tool that interacts with the master environment within the Kubernetes network and allows all the instructions that are pushed to the kubelet and to Docker to be able to perform effectively. So let's have a look at some of the companies using Kubernetes. There are a lot. And if you're doing any work today in the cloud, or even if you're just starting off and doing some simple work in the cloud, there's a really good chance that you are using Kubernetes. But some of the companies that you are probably not surprised are using Kubernetes Kubernetes are Spotify, SAP, eBay, and of course some of the big companies out there, Google with their entire network of solutions, and Microsoft with Office and their tools. So let's take a step into now let's have a look at a Kubernetes use case. And in this example, we're going to look at the New York Times and how they use Kubernetes to solve a problem that their IT department was struggling with. So when New York Times started working out of their data centers, their actual deployments were small and the applications were managed across VMs. But the problem is that as New York Times became more of a digital company, they started building more digital solutions. And at some point, they realized that what they needed to do was to embrace the cloud and move all their solutions to the cloud. However, their first step of using the cloud, and this is, I think, typical for a lot of companies, is that they treated the cloud-hosted provider in the same way as they would with a data center. And at some point, they realized they had to take a change. And this is where the development team came in and they said, look, how about we stop thinking of our solutions as a data center, even though they're being run in Amazon, and start thinking of them as cloud-first solutions. And so what they proposed and what they ended up doing was using Google Cloud Platform with Kubernetes as a service to provide greater efficiency. And so by using Kubernetes, they had the following advantages. They're able to deliver solutions at a much faster speed, and in the world of digital content, speed is everything. They were able to reduce the time for deployment from minutes to seconds, and by doing this, they were able to increase the amount of time, uptime for the actual infrastructure. Updates began to be deployed independently and when required, so you didn't have to schedule an event when you do the deployment. It just happened. And there was a more unified approach to deployment from the engineering staff, which just made the whole solution more portable. So the fundamental end line for the New York Times is that by leveraging Kubernetes, they were able to automatically manage their deployments and scheduling of solutions instead of having to do solutions through a more traditional ticket-based system. It just really speed up the efficiency of the New York Times website. So let's finally kind of look into some of the important terminologies before we take our time to do a demo. So we have 6 terms that we're going to look through, and we'll let you read through these, but we have a cluster, which is a set of machines, physical or vertical, in which applications are managed and run. We have a node, that are the worker machines that run containerized applications and other workloads. There is the pod, which is within a node and is a group of containers that are deployed together on the same host. We have replication controllers, and a replication controller is used to define a pod's life cycle rather than to create the pods directly. We have a selector, which is an expression matched label to filter specific resources. Labels are key value pairs that are attached to objects such as pods. The key value pair or the label can be filter, organize, and perform operations on resources. Replication sets define how many replicas of each pod will be running and managed when you want to either replace a pod when it dies. Annotation is a label with much larger data capacity. A name is a resource as it is identified. Volume is the directory in which data is accessible to a container. Namespaces provide additional qualification to a resource's name. And then finally, service is an abstraction of a top-tier pods which provide a single IP address and DNS name by which the pods can be accessed. So at this time, what we want to do is take you through Kubernetes demo, actually runs through some of these basic controls. So we're going to take you through a video of how to actually install Kubernetes and to use some of the basic instructions. So Kubernetes is the most widely used platform for container management. The first step is to actually install the necessary dependencies. So let's see if there's any updates first. So to check if there's any updates, we're going to use the command sudo apt-get update. We're going to enter in our password, and this looks like it's going to take a few minutes because we've got a few updates that need to be running. All right, we're done. All right, next we're going to write sudo apt-get install -y apt-transport-https, and this will install all of the dependencies we need to actually start installing the solutions needed for Kubernetes. All right, that was quick. Now we're going to put in the Docker dependency, and the way we do that is write the command sudo apt install docker.io. I've got a typo, correct that quickly, and put in y, so for yes, and we continue. And it's going to take a while because we're going to download and install Docker off the internet, and it's quite a large installation. Now would be a good time to go get a cup of coffee because it'll take us about a minute to get this all done. Once we actually have Docker installed, we'll actually go ahead and we'll start Docker and enable Docker using our sudo commands. Alright, so that's all done. So let's start to enable Docker. We're going to use sudo systemctl start Docker and sudo systemctl enable Docker. This will be quite quick. So the next step is to install all the components for Kubernetes, and we're going to install the curl command and then kubelet, kubec, and then kubeadm. We're going to install all the necessary tools. We're going to do the curl command, kubelet, kubec-c2, and kubeadm. And so let's go ahead and put in the sudo apt-get install curl. We're going to get a prompt. We can say yes for that. And then after this, we'll go ahead and install Kubernetes. So the first, what we're going to do is we're going to actually put in the Kubernetes key. So that's going to be sudo curl-s, and then we have a long URL, which is https packages.cloudgoogle.com apt-doc apt-key.gpg sudo apt-key. There we go. Correct my typo there. Okay, now we have to go ahead and change permissions of a folder. So we do that with sudo chmod 777 /etc /apt /sources.list.d. All right, we're good. Okay, now you want to go ahead and open up your text editor, and we're going to make an actual edit, and we're going to create a simple file. And so what we're going to type in is the following command: db http apt-kubernetes.io /kubernetes-xenial main. And we're going to save this file in the etc folder, and then look for, and then apt, which is going to be down a little bit. And there we have it. And we're going to save it in the apt-get updates. And we're going to name this file as kubernetes.list. And we'll save that. And then we can close out the notepad and go back to the terminal window. And let's look and see if there are any updates again. So we're going to go ahead and run apt-get update. And it's going to run any updates from what we've created. And we want to check what's in the folder. And so we can do cat /etc/apt/sources.list.d/kubernetes.list. And there we are. It shows what we have in that text file. And so we're going to go ahead and we're going to install kubelet, kubec2, and kubeadm. But first we're going to have to initialize the master. I'm going to show you an error you would get if you were to install kubelet and the other files too quickly. You get the following error. All right, so we have installed kubelet, kubeadm, kubectl, and Kubernetes CNI. And so we're going to go ahead and use sudo swap-up -a. And now we're going to initialize the master node. And we're going to do that with sudo kubeadm init. And this will take a few minutes for it to initialize. All right, so that's all done. All right, so we're going to deploy the pod to a network. And we have two commands that we're going to use. We use sudo kubectl apply, and then we have a long path we have to type out, which is -f https raw githubs content.com corios flannel master documentation kube-flannel.yml. What we have to do is we have to actually go ahead and deploy the nodes first. So we're going to do that by creating mkdir-p, and then we have $home-.cube. We'll create that new directory, and sudo cp-i, and then the path will be etc/kubernetes/admin.conf, and then $home/.cube./config. And then the final one will be sudo chown $open paren id-u close paren $open paren id/-g close paren $home/.cube/config. All right, now we're going to go ahead and deploy, and let's see. Oh, yeah, I think I have a typo in my command here. Yep. Oh, yeah, I did have a typo. And so I've got that incorrect now. So documentation is actually spelled with a T, not an S. And then we're going to go ahead and we're going to put in the next line, which is sudo kubectl apply -f, and then we're just going to change a little bit of the actual link here, and that runs great. And now we want to be able to see all of the pods that we have in our network, and so we're going to do that by writing the command sudo kubectl get pods -all -namespaces, and it should list all of our pods. We only have one. There we are. There's all of our content. Now we're going to, so there's only one node, so let's see what we have here. So we're going to use the command sudo kubectl get nodes. There we are, just one node. So our final step is to actually go ahead and deploy a service. And so what we're going to go ahead is deploy the nginx service. And we're going to do that with the command sudo kubectl run --image equals nginx. And we're going to put this into port 80, so it's going to be nginx-app --port equals 80 --environment env equals open quotes domain equals cluster close quotes. And we're going to write one more command, which is sudo kubectl expose deployment nginx-app --port equals 80 --name equals nginx-http. And once we've done this, we'll be able to then run the command to actually see our services. And there'll be quite a few of them. And our final command is sudo docker ps-a. There we are, quite a lot of lists, quite a lot of services listed. So there you are. That's the instructions on how to get Docker up and running, and with some basic commands. It's worth going through a few times to get right, but once you actually have the Kubernetes environment up and running, managing your Docker environment and containers, it's extremely powerful.
If getting your learning started is half the battle, what if you could do that for free? Visit SkillUp by Simplilearn. Click on the link in the description to know more.
Welcome to Kubernetes architecture from Simplilearn. We're going to take a deep dive into the Kubernetes architecture. If you're new to Kubernetes, we already have an introduction that goes and provides an overview of Kubernetes, and we have the link below so you can go straight to that if you want to have a refresher. Otherwise, hang around and join us in this presentation. And if you want to see more of these videos, hit the subscribe button, and if you want to get notified, hit the notification bell, and every time we post up a new video, you'll get the notification right onto your phone or on your desktop that the new video has been uploaded. And as always, if you have any questions, please post them in the comments below. We do read the questions and we try to respond to all of them as quickly as we can. With that said, let's jump into Kubernetes architecture. So we're going to break out the presentation into the following areas. We're going to cover what Kubernetes is and why you want to be using it. We're going to introduce the actual architecture and provide an overview of how it contains the containers and the other components that you'd have within the architecture. We'll also compare Kubernetes with Docker Swarm. And one of the things that you hear with Kubernetes almost in the same breath is Docker. We have to be careful not to confuse Docker from a container point of view and Docker Swarm, which is a container management tool. And Kubernetes is also a container management tool, so we'll compare the two of those. And then we'll look at the hardware and software components, and then finally do a deep dive into the architecture of Kubernetes and provide a case study of where Kubernetes has been used successfully in the past. So let's jump into this. So what actually is Kubernetes? So Kubernetes is a tool that was designed to actually help manage and contain large groups of containers. It was developed originally by Google out of the Google Borg solution, and then open sourced by Google. The actual environment allows you to manage large groups of containers. So if you're a developer in DevOps and you're working with Docker, then you're used to the concept of a container. And you'll also know that containers and cloud technologies tend to be almost breathed in the same breath. So the work that you're doing with Kubernetes is to be able to manage large groups of containers inside of the cloud. The thing that's great about working with Kubernetes is that it is incredibly flexible flexible, and it allows you to have incredibly complex applications run efficiently. So let's step into why you'd want to use Kubernetes. So a couple of key points. Kubernetes itself is an open source solution originally developed by Google, but it is available on most cloud platforms today. So AWS, Google Cloud, Microsoft Azure, all of them support Kubernetes. And what you'll find is as you're setting up your infrastructure, particularly if you're using containers, you'll see that the support for Kubernetes is floated up very, very efficiently and effectively by all three vendors. It's extremely useful for being able to manage large modular environments, and that's really kind of I think one of the big benefits of Kubernetes is its modularity, is that it really breaks down containers into their smaller parts. And once you do that, it becomes much more efficient for you as an administrator to be able to manage that entire environment. The reproducibility of Kubernetes is extremely high. You can build out infrastructures very quickly and have them being able to manage and have containers coming on and off and killed and created to be able to help load balance your entire environment. And so again, we keep talking about containers, but that's really what Kubernetes is all about, is being able to manage your applications that are managed through containers and being able to do that in a virtualized infrastructure. And the thing that's also really good with Kubernetes is it's really easy to deploy solutions. You just have to use a simple curl call and you can actually push out your Kubernetes infrastructure. So let's have an overview of the Kubernetes architecture. So Kubernetes is really broken up into three key areas. You have your workstation where you develop your commands and you push out those commands to your master, and the master is comprised of four key areas which essentially control all of your nodes, and the node contains multiple pods, and each pod has your Docker container built into it. So consider that you could have really almost an infinite number of infinite number of nodes being managed by the master environment. So you have your cluster, which is a collection of servers that maintain the availability and the compute power, such as RAM, CPU, and disk utilization. You have the master, which is really components that control and schedule the activities of your network. And then you have the node, which actually hosts the actual Docker virtual machine itself and be able to actually control and communicate back to the master the health of that pod. And we'll get into more detail on the architecture later in the presentation. So you keep hearing me talk about containers, but they really are the center of the work that you're doing with Kubernetes. And the concept around Kubernetes and containers is really just a natural evolution of where we've been with internet and digital technologies over the last 10-15 years. So before Kubernetes, you had tools where you're either running virtual machines or you're running data centers that had to maintain and manage and notify you of any interruptions in your network. Kubernetes is the tool that actually comes in and helps address those interruptions and manages them for you. So the solution to this is the use of containers. So you can think of containers as that natural evolution from 15, 20 years ago. You would have written your code and posted it to a data center. More recently, you probably posted your code to a virtual machine and then moved the virtual machine. Now you actually just work directly into a container, and everything is self-contained and can be pushed out to your environment. The thing that's great about containers, they're isolated environments, very easy for developers to work in them, but it's also really easy for operations teams to be able to move a container into production. So let's kind of step back and look at a competing product to Kubernetes, which is Docker Swarm. Now, one of the things that we have to remember is that Docker containers, which are extremely popular, are built by the company Docker and made open source. And Docker actually has other products. One of those other products is Docker Swarm, and Docker Swarm is a tool that allows you to be able to manage multiple containers. So if we look at some of the benefits of using Docker Swarm versus Kubernetes, one of the things that you'll find is that both tools have strengths and weaknesses. But it's really good that they're both out there because it helps it really kind of justifies the importance of having these kind of tools. So Kubernetes was designed originally from the ground up to be auto-scaling, whereas Docker Swarm isn't. The load balancing is automatic on Docker Swarm, whereas with Kubernetes you have to manually configure load balancing across your nodes. The installation for Docker Swarm is really fast and easy. I mean, you can be up and running within minutes. Kubernetes takes a little bit more time, is a little bit more complicated. Eventually you'll get there. I mean, it's not like it's going to take you days and weeks, but it is a tool that's, when you compare the two, Docker Swarm is much easier to get up and running. Now, what's interesting is that Kubernetes is incredibly scalable, and it's, that's its real strength, is its ability to have strong clusters. Whereas with Docker Swarm, its cluster strength isn't as strong when compared to Kubernetes. Now, you compare it to anything else on the market, it's really good. So this is kind of a splitting hairs kind of comparison, but Kubernetes really does have the advantage here if you're looking at the two compared to each other for scalability. I mean, Kubernetes was designed by Google to scale up and support Google Cloud network infrastructure. They both allow you to be able to share storage volumes. With Docker, you can actually do it with any container that is managed by the Docker Swarm, whereas with Kubernetes, it manages the storage with the pods, and a pod can have multiple containers within it, but you can't take it down to the level of the container. Interestingly, Kubernetes does have a graphical user interface for being able to control and manage the environment. The reality, however, is that you're likely to be using terminal to actually make the controls and commands to control your either Docker Swarm or Kubernetes environment. It's great that it has a GUI to get you started, but once you're up and running, you're going to be using terminal window for those fast, quick administrative controls that you need to make. So let's look at the hardware components for Kubernetes. So what's interesting is that Kubernetes is extremely light. Of all the systems that we're looking at, it's extremely lightweight. It allows you to have, if you compare it to like a virtual machine, which is very heavy, Kubernetes is extremely lightweight and hardly uses any resources at all. Interesting enough, though, is that if you are looking at the usage of CPU, it's better to actually take it for the cluster as a whole rather than individual nodes, because the nodes will actually combine together to give you that whole compute power. Again, this is why Kubernetes works really well in the cloud, where you can do that kind of activity rather than if you're running in your own data center. So you can have persistent volumes such as a local SSD, or you can actually attach to a cloud data storage. Again, Kubernetes is really designed for the cloud. I would encourage you to use cloud storage wherever possible rather than relying on physical storage. The reason being is that if you connect to cloud storage and you need to flex your storage, the cloud will do that for you. I mean, that's just an inherent part of why you'd have cloud storage. Whereas if you're connecting to physical storage, you're always restricted to the limitations of the physical hardware. So let's kind of pivot and look at the software components as compared to the hardware components. So the main part of the components is the actual container, and all of the software running in the container runs on Linux. So if you have Docker installed as a developer on your machine, it's actually running inside of Linux. That's what makes it so lightweight. And really, one of the things that you'll find is that most data centers and cloud providers now are running predominantly on Linux. Inside of the container itself is then managed inside of a pod, and a pod is really just a group of containers bundled together. And the Kubernetes scheduler and proxy server will then actually manage how the pods are actually pushed out into your Kubernetes environment. The pods themselves can actually then share resources for both networking and storage. So pods aren't pushed out manually. They're actually managed through a layer of abstraction and part of their deployment. And this is the strength of Kubernetes. You define your infrastructure, and then Kubernetes will then manage it for you. And there isn't that problem of manual management of pods if you have to manage the deployment of them. That's simply taken away, and it's completely automated. And the final area of software services is on ingress, and this is really the secure way of being able to have communication from outside of the cluster and passing of information into that cluster. And again, this is done securely through SSL layers, and allows you to ensure that security is at the center of the work that you have within your Kubernetes environment. environment. So let's dive now into the actual architecture before we start looking at a use case of how Kubernetes is being employed. So Kubernetes, again, is we looked at this diagram at the beginning of the presentation, and there are really three key areas. There's the workstation where you develop your commands, and then you have your master environment, which controls the scheduling, the communication, and the actual commands that you have created, and pushes those out and manages the health of your entire node network. And each node has various pods. So we break this down. So the master node is the most vital component. With the master, you have four key controls. You have etc., controller manager, scheduler, and API server. The cluster store, etc., this actually manages the details and values that you've developed on your local workstation, and then we'll work with the controller, schedule, and API server to communicate that out, those instructions of how your infrastructure should look like to your entire network. The control manager is really an API server, and again, this is all about security. So we use RESTful APIs, which can be packaged in SSL to communicate back and forth across your pods and the master, and indeed the services within each of them as well. So at every single layer of abstraction, the communication is secure. The schedule, as the name would imply, really schedules when tasks get sent out to the actual nodes themselves. The nodes themselves are dumb nodes. They just have the applications running on them. The master is really doing all of the work to make sure that your entire network is running efficiently. And then you have the API server, which has your REST commands and the communication back and forth across your network that is secure and efficient. So your node environment is where all the work that you do with your containers gets pushed out to. So a work is really it's a combination of containers, and each container will then logically run together on that node. So you'd have a collection of containers on a node that all make logical sense to have together. Within each node, you have Docker, and this is your isolated environment for running your container. You have your kubelet, which is a service for conveying information back and forth to the service about the actual health of the Kubernetes node itself. And then finally, you have the proxy server, and the proxy server is able to manage the nodes, the volumes, the creation of new containers, and actually helps pass the health of the container back up to the master to see whether or not the containers should be either killed, stop started, or updated. So finally, let's see where Kubernetes is being used by other companies. So, Kubernetes is being used by a lot of companies, and they're really using it to help manage complex existing systems so that they can have greater performance, and with the end goal of being able to delight the customer, increase value to the customer, and hence increase value and revenue into the organization. So an example of this is a company called BlackRock, where they actually went through the process of implementing Kubernetes. So BlackRock had a challenge where they needed to be able to have much more dynamic access to their resources. They were running complex installations on people's desktops, and it was just really, really difficult to be able to manage their entire infrastructure. So they actually then pivoted to using Kubernetes, and this allowed them to be able to be much more scalable and expansive in the management of their infrastructure. And as you can imagine, Kubernetes was then hooked into their entire existing system and has really become a key part of the success that BlackRock is now experiencing of a very stable infrastructure. And the bottom line is that BlackRock is now able to have confidence in their infrastructure and be able to give that confidence as back to their customers through the implementation and more rapid deployment of additional features and services.
Kubernetes specific to AWS Cloud Platform. So what's a part of this tutorial and demo? What's in store for you? At our offset, I would like to cover the basics of orchestration tools. As most of you would know, Kubernetes is one of the most popular orchestration tools in recent times, specifically for applications which are cloud native and deployed on some or the other types of containers. But what are these orchestration tools? Why would one need to use orchestration tools? What are the facilities or features provided by these orchestration tools? That's the first thing that I'm going to cover. After that, I will pick two orchestration tools specific to container management, Docker Swarm versus Kubernetes. I'm going to compare them with regard to the features that they provide, the use cases that they cover, what facilities that they provide, and when to use what. After that, I will get into a little bit details of the Kubernetes architecture, what exactly is required for setting up a Kubernetes cluster, what runs in a control plane or a master node, what runs as a part of the worker node. After that, I will end the tutorial by running you through a demo by setting up a 3-node Kubernetes cluster on AWS platform. I will use something called as kops, which is one of the admin tools for setting up production grade Kubernetes cluster. So I will use this to set up a 3-node cluster on AWS. All right, now that we set the context right, let me get started. So what are orchestration tools? The application development and the lifecycle management from the time the application is developed, connecting the source code to your continuous integration, to testing them all along your development process, and eventually moving it down to production, managing your production servers, the dependencies that your software has, the requirement that it has in terms of the hardware, the features of fault tolerance, self-healing capabilities, auto-scaling, all this has complicated over the last few years. As a part of DevOps, one thing that everyone is interested in is managing all this application dependency or lifecycle management using some or the other kind of a tool. So that's where these orchestration tools have become very, very popular. So what kind of features that they provide is you'll have to just let them know what are the kinds of tool sets that is required, what are the fault tolerance mechanisms that it has to be adopted to, what kind of a self-healing capabilities that application will have to need, and if at all there is any auto-scaling features that is required. If at all you can bake in all these specific parameters into your tool, your orchestration tool becomes a one-stop shop for all your deployment and configuration management needs. That's where these orchestration tools have become a very, very popular and relevant, specifically these days when people are more and more interested in adopting DevOps practices. All right, so having said that about orchestration tools, let's concentrate on 2 of these orchestration tools specifically for container management: Docker, Swarm, and Kubernetes. Many of the applications that are written for these kind of containers are called or kind of fall into a category of cloud native, where the application need not know much about the underlying infrastructure or the platform where these applications are running. So these two, along with Apache Mesos, there are many other container management systems, but I'm going to pick Docker, Swarm, and Kubernetes for comparing the features that is provided by these 2 frameworks. For the sake of comparison, I picked up Docker Swarm and Kubernetes just because of the reason that both of them operate in the space of container management. They do something very, very similar to containers. That's the similarity that exists between these 2 orchestration tools. However, there's a big difference that exists when it comes to the types of containers that both of them cater to, and also the capacity of workloads they can be used for. Docker Swarm is a cluster management solution that is provided by Docker Container. Docker is one of the very, very popular containers of recent times, and in case you have your applications that is totally powered by only Docker containers, if you have a need where you want to run a cluster of servers which are running only Docker containers, Docker Swarm should be your choice for your orchestration tool. Kubernetes, on the other hand, can cater to any other types of containers other than Docker, and including Docker as well. So in case you have your applications which have got Docker in them, which have got RKT in them, which they have got LX in them, or any other type of container, Kubernetes should be your choice of orchestration tool. A Docker Swarm can manage up to 40, 50, or 60 max nodes. So in case your application is totally written in Docker containers and the load or the expected cluster size is about 50, 60 nodes, Docker Swarm should be your choice of orchestration tool. On the other hand, Kubernetes is something that was open sourced by Google, and the scale of operations that Kubernetes can cater to is Google scale. So if in case your applications are more than 1,000 nodes, that is where Kubernetes comes into play. That's the big difference that exists between Docker Swarm and Kubernetes. Putting those differences aside, let me compare Docker Swarm and Kubernetes based upon other features which are similar in nature. The first and important feature that Kubernetes provides is something called as auto scaling. If at all the load on your cluster is too high and your application is experiencing more load, so Kubernetes can add new nodes to your cluster. Of course, you'll have to configure Kubernetes in order to have those capabilities where it can spin up new VMs or new nodes. If at all you do that configuration correctly, Kubernetes has got the capacity, or it has got the feature where it can bring up a new node and add it to the cluster on the fly based upon the load that exists at that moment. On similar lines, if at all the load is not too high, it can identify a few of those nodes which have got less number of replicas or less number of application containers running on it. It can move them to some other node and also scale down by deleting few nodes from your cluster. So that is the powerfulness of auto scaling which is provided by Kubernetes, and this unfortunately does not exist in Docker Swarm. The other feature of load balancing, specifically application load balancing. So Docker Swarm gives you an application level auto load balancing. However, Kubernetes gives you the flexibility of manually configuring any other type of load balancer of your choice for application load balancing. Installation. As I mentioned earlier, Docker Swarm is a loose cluster of containers which are running on nodes. It is very easy to spin up a new node and then connect them to a swarm. And this can be done in a very loosely coupled way where you can create swarms of your choice. Nodes are allowed to connect to swarms and quit or leave the swarms on the fly. So in and all, the installation is pretty easy and fast. Kubernetes, on the other hand, the configuration of Kubernetes, the way to spin up a big cluster specifying the size of the node, how many master nodes, how many config planes that you want, how many nodes that you want. It's a pretty tough thing to bring up a Kubernetes. Scalability. Kubernetes strength is very strong. They are very tightly coupled, and even they have the capability where on the cluster size things or the nodes can be increased on the fly based upon the requirement. On a Docker Swarm, the cluster strength is weak as compared to Kubernetes. Worker nodes can be added to a swarm. Worker nodes can be asked to leave a swarm or can be taken out of a swarm based upon the requirement. So this is kind of a loosely coupled architecture for Docker Swarm, while Kubernetes, the cluster is very tightly coupled. Since Docker Swarm runs only Docker containers, containers find it very easy to share data and a lot of other things with each other because they all have the same signature. They are all from the same family. So it's very easy for them to share not just volumes, but a lot of other things. However, for Kubernetes, since it manages containers of different types, if your application has to share some data across different containers, there's a little bit of a complexity in how you would want your containers to share data. Also, when it comes to Kubernetes, Kubernetes groups containers in something called as pods. While a pod can have either one container, that's the preferred choice, or multiple containers. And the idea of pod is like each pod can run in any other node. It's not guaranteed that you would want to have 2 or 3 pods to be running on the same node. That makes data sharing a little bit of a different thing compared to Docker Swarm. GUI. So there's not a good enough UI tool in Docker Swarm, at least the CE edition of it, which will allow you to get to know what is running on your containers, what is the size of the containers, what is the volume of the containers, and all that stuff. There are some free and open source tools like Portainer, which gives you a good visibility into your running Docker containers. However, there's nothing at a swarm level that is provided by Docker. Kubernetes gives you an out-of-the-box dashboard, which is easy to configure and set up. You can also club it with some metrics services, and you can also get information about the size of the cluster that is running, what is the load on the nodes, and stuff like that. All this across your cluster in a very beautiful dashboard perspective. So that way, there's a little bit of a good UI for Kubernetes, while for Docker Swarm, there isn't anything that is provided out of the box. Let me spend some time in explaining a little bit about the Kubernetes architecture, what comprises of the Kubernetes cluster, what resides in a master or a control plane, and what resides in a worker node. This is a very high level depiction of a Kubernetes cluster. So this is the master node, which has got something called as a cluster store, a controller, a scheduler component, and an API server. And these are the bunch of nodes that are connected are administered by the master node. The master node can be 1, 3, 5, typically an odd number. This is as per the typical cluster management thing where you would need the master nodes to be in odd numbers so that whenever there's any contention in terms of what needs to be deployed where or where to give the job to whom and stuff like that, all the masters would cast their vote and they would decide on the outcome. So that's the master node, and there are a bunch of nodes which can be connected and administered by the master node. kubectl, or the command from using which anybody can assign some workloads to the cluster, can also be run either on the same node or on a separate node. So kubectl is the command line tool that we will be installing and using in order to fire up our commands to our cluster. So if at all I have to put up a job on our cluster, if I have to give out any specific commands to my cluster, all this is done using kubectl. There's a bunch of REST APIs which is used by kubectl, and kubectl will talk to the API server and fire up the commands specific to my cluster. What runs in the master node? Master node, without saying, it's the most important component of any of the cluster. If at all you're running cluster with only one master node, if your master node goes down, there's no other way that you can, or any user can talk to the different nodes in the cluster. So master node is the most vital component responsible for the complete Kubernetes cluster. There's always one node that should be running as a master node. That's the bare minimal requirement for your cluster. So what are the other components in the master node? The most important one is called etcd. So this is nothing but a data store, a value of key value pair which is stored, which contains all information about your cluster. So all the configuration details, which node is up, which worker node is down, all this information is stored in the cluster store. So all the managers would access this cluster store before they go ahead and decide any other work item or anything else that has to be done specific to your cluster. What's in the controller? As the name says, controller is something, it's like a daemon server that is running in a continuous loop. All the time it is responsible for controlling the set of replicas, the kind of workloads that is running based upon the configuration that the user has set in. So if at all, if you are aware of something called as replication controllers, endpoint controllers, namespace controllers, all these controllers are managed by the controller component. If any user asked for some 3 replicas of a particular pod or a service to be running, and if at all any of the nodes goes down or the pod goes down for whatever reason, the controller is the one who wakes up and assigns this particular job or the pod to some other available node by looking up for the details using in the cluster store. That's the importance of the control manager or the controller. The scheduler assigns the tasks based upon whoever has asked for any job to be scheduled, based upon a time frame or based upon some criteria. It also tracks the working load as to what exactly is the load, who is running what in the cluster, and places the workload on whoever is the available resource at that time. Alright, API server. This is one other important component in our Kubernetes cluster, where how would the end user deploy or give out any sort of a workload onto your cluster? All the requests come to the API server. So this is an entry point for all your requests that come into your cluster. Anybody wants to deploy something, anybody wants to scale up a controller, anybody wants to bring down few services, anybody wants to put in a service, all this will have to come in as a part of a REST API endpoint. And API server is the entry point. In case you don't want somebody to access your cluster, in case you want only specific people or specific users to be running some specific workloads, you can set all those role-based access control for this API server. So this is the entry point for anyone who wants to submit any job to your cluster. So that's a quick overview about the master node. What are the important components of a master node? Now let's go over to what runs in a worker or a slave node. As I mentioned earlier, slave nodes are something where the job that is submitted to your cluster is eventually run as a pod, as a service, as a container. So in Kubernetes world, there is something called as a pod. A pod is nothing but a combination of a container. It is a wrapper around your running containers. So slave nodes or the worker nodes typically run these pods. So that is where the whole workload typically gets run. But there are a bunch of other components in the node which also manages what runs in the pod, who has to have access to the pod, what is the state of the pod, is it in a running state, is it going down for some reason, and all that stuff. So let's quickly go over those components that is there in the slave node. The most important component, in my opinion, that should be on the node should be the container runtime. As I mentioned earlier, Kubernetes can run any different types of containers, not just Docker. So in case you want to have a node which wants to have Docker running on it, RKT running on it, LKC running on it, or any other container environment that is running on it, you have to ensure that the specific container runtime environment is available on that specific node, so that whenever a job is submitted, a description of what needs to be run as a part of the pod, what should be the image with which it should be powered, and what kind of a container to spin up. So that's what, when the job is finally assigned to this particular node, it would definitely need a container runtime to be up and running. So that exists only if at all the container runtime is installed and running on your Kubernetes worker node. Okay, now that we know what our Kubernetes node can run, how would somebody assign a job to our node? That is using something called as a kubelet. As the name says, kubelet is a small subset which talks to the kube API server. So any node which has to run any kind of a pod, all these instructions are passed around by the kube API server to the kubelet, and kubelet is capable of processing whatever job that is assigned to it and ensuring that so many pods and so many services are spun up based upon the requirement. The last component that exists in the worker node is the kube proxy or Kubernetes proxy. This plays a very, very important role, acting as a load balancer and a network proxy. So what typically happens is whenever the pods are running in nodes, the pods can be typically running in any node. There is no affinity towards any node on which these pods are running, because pods or containers are something called as ephemeral. They can run anywhere. So how would somebody reach out to these applications that is running in some pod which is running in one container now and running in probably another container, another node altogether tomorrow? So that is where your Kubernetes proxy comes into picture, and this component will ensure that any container that is spun up or any pod that is spun up, it keeps track of all these pods and kind of connects the endpoints or acts like a DNS server, so that it knows when somebody is trying to reach out to this particular service, which is the pod on which the service is typically running. So that plays a very, very important role by acting as a load balancer and a network proxy. Now that at a very high level we know what are all the components that make up of our Kubernetes cluster, let's go ahead and create a small cluster. We'll spin up this cluster on AWS platform. Finally, we get to the demo section of my tutorial. Now that you guys are aware as to what is Kubernetes, what is the use of Kubernetes, you also know at a very, very high level what are the components of a cluster. What is a master node or a control plane? What are the components of a master node, and what should be existing in a worker node? You're probably thinking that it's maybe pretty hard to kind of set this up. So let me demystify that by running you with a quick demo of how to set up a simple 3-node Kubernetes cluster using a tool called kops. And I will be doing this whole setup on my AWS cloud. Okay, so what is kops? Kops is nothing but a simple tool. This is an admin tool that allows you to bring up production grade Kubernetes environments. As I said, setting up a Kubernetes cluster on a bare metal is a little challenging. So that is why I would use something called as a kops, and I will use this on my cluster, which I will spin up on my AWS instance. So I have an AWS account, and what I will do first is I will first spin up an EC2 server. I will power this with one of the Linux AMIs, and I will install kops on it. Now this will be my starting point from where I'm going to trigger running up a big cluster. In our case, I'll try to keep it little small. I don't want too many nodes in my cluster. I'm going to have one master node and 2 worker nodes. This whole operation would be done programmatically by installing this kops admin tool. So as you may know, AWS, it's a little hard for me to programmatically run other components or rather bring up servers. It's not pretty simple. So what I would do is I will create an IAM role which will attach to my EC2 server, so that my EC2 server gets powered with all the required role, so that it can go ahead and spin up cluster based upon my configuration that I'm going to specify. Alright, so once I have my cluster set up, I will also install kubectl, which you would probably know by now is nothing but a command line utility using which I can kind of connect to my cluster, give out some jobs, put some pods and stuff like that. So I will use kubectl. I will also have a pair of SSH keys so that from this machine, I would be able to successfully get onto the master node and submit jobs on my behalf. So let me begin by first logging into my AWS account. All the steps that I will be following to bring up my AWS cluster, Kubernetes cluster, will be documented, and I'll be sharing you this document in a GitHub repository so that in case anybody wants to try, you'll be more than happy to find all the required instructions in one place. Okay, now the first thing that I would need is to launch an AWS EC2 instance. Now this is an instance where I'm going to install kops and I will use it as a base server from where I'm going to fire some commands which will bring up my Kubernetes cluster. So let me log into my AWS account and let me stick to one particular region and let me bring up one EC2 instance. All right, so let me launch my instance. Let me choose, doesn't matter either ways, but in case you want to try it on your free tier, I would recommend choose free tier only and choose an AMI of your choice. Let me choose this instance. I will make it T2 micro. That is good for me. Configuration, instance details. All right, I don't want to change anything here. That looks good. Maybe I will change this 30 gig. That's good for me. Let me add a tag to my instance. I will name this as my kops server. All right, I would need a bunch of ports to be opened up. So what I will do is I will create a new security group called Open to the Word. I would not recommend that you do this since I don't want to. It will take a long time for me to specifically pick and choose the ports that has to be open for running my cluster. I don't want to do that. I will open up all the HTTP and HTTPS ports so that it's quicker. So I will say all TCP. I would say from anywhere, just to be on the safer side. I also open HTTP and HTTPS, and I will make this anywhere and anywhere. This is good for me. I will say review and launch. All right, so I chose a T2 micro instance. Just for the sake of easiness, I've opened up all the ports, and the instance details are, you've seen what is that I've chosen. All right, now important part is like I would need a key pair. I need to create a new key pair. I will call this as Simplilearn keys. I will download this key pair and then I will launch the instance. It will take some time for my EC2 instance to come up. In the meanwhile, what I'll do is I will convert. I have this PEM file, which is the pair of keys, the SSH keys with which I need to log into my EC2 instance. So I'll need to convert this because I'm trying to connect from my Windows box. I would need to convert this into a PPK file. So I have puttygen. I'm going to load my set of keys here and convert that key into a PPK key. All right, open. All right, I would say save. Hang on, save private key. Yes, I would say Simplilearn or Simplilearn private key. I'll save this here. Done that. That's all. So this is my public key, which is the PEM file, and this is my PPK or my private key. Now using the private key, I will log into my EC2 instance. Okay, now my EC2 instance is up and running. It is running in this Ohio region, and this is the IP address of my public IP address of my machine. So let me connect to it. So I use MOBA Xterm, which is nothing but an SSH emulator. You can use PuTTY or any of these sessions which allow you to do an SSH. This is my IP address of my machine, and since I've spun up an Amazon AMI, this is the default user. I would need to specify the private keys for my session, and this is the private key for my session. Say OK. I am in my Amazon EC2 instance. So let me look at what are the other things that I need to do. All right, so as I said, I just brought up my EC2 instance, but I would need my EC2 instance to run few things on my behalf so that it can spin up other EC2 instances. It can also talk to an S3 bucket where I'm going to store the instance state of my Kubernetes cluster. Also some sort of an auto scaling group because I want to spin up more and more instances. I also want to have a private hosted zone using my Route 53. So I would need my EC2 instance to have all these sort of permissions for my server. So what I would do is I will go and create a permission a role in the EC2, or rather in the AWS IAM role, and I will attach this IAM role to my EC2 instance. All right, so let me go to my IAM, which is nothing but the identity and access management. I will create a role called as possibly COPS role. I will create a role. This role will be used by my EC2. So I'm going to click on EC2. I will say next permissions. They would need a lot of permissions, specific permissions to be very honest. And the permissions are all listed out here, S3, EC2 and all this stuff. Just to keep it pretty simple, what I would do is I will create a role with the administrative access. All right, so I don't want any tags. I'm going to review. I'll create a role name. I will say COPS role for EC2. All right, so I'm going to create a role which has got administrative access roles. I'm going to create a role. So this would ensure that my EC2 instance from which I'm going to run my cluster would have all the prerequisite permissions so that it can go and spin up instances, talk to S3 buckets and all that stuff. All right, now let us have our running instance get powered by this role. So I will connect this role to my running instance. All right, so this is my EC2 instance that is running. I will say action, attach, replace IAM roles. So there is no role as of now. I would want my COPS role for EC2. This is the role that I created. So I want this new role to be assigned to my EC2. All right, great. Now my EC2 instance, which is my COPS server, has got all the required permissions so that he can create a cluster on my behalf. Great. Now before this, let me do a sudo yum update -y. So that any of the, because this is a newly provisioned VM, I just want to ensure that all my system libraries are all updated. So that when I do install COP and kubectl and all those things, none of them will fail because of some dependency or package issues. So I'm just running a sudo update -y so that all the libraries are updated. Okay, looks like it is done. So let me go ahead and install COPS. COPS is a pretty simple installation. It is available in a particular location. I have to just copy this and ensure that I do a curl and I install this particular stuff. All right, so it is fetching the COPS tool. It's installing for me. Once it is copied down, let me change the mode so that I can execute it, and then also let me move it to my user local bin so that it is available for me in my path. Okay, that's pretty much the COPS installation. Let me also do one other thing. Let me install something called as kubectl. So this is what would be, a tool using which I'm going to be firing my commands to my Kubernetes cluster once it comes up. Right, this is a pretty smaller executable. So kubectl. All right, so I have kubectl as well as COPS installed on my EC2 server now. Okay, now what I'll do next is I'm going to create an S3 bucket in AWS so that the Kubernetes cluster state is persisted in this bucket. So let me create a simple bucket with this name, S3 bucket with this name. So let me go to S3 and let me create a simple bucket with this name. I will just say create a bucket. Okay, so the simplilearn.kubernetes is the bucket that I created. So this bucket will store all information about my cluster. Let me now go and create a DNS entry or a DNS zone or a AWS Route 53 hosted zone for my cluster. So this is required so that I can give a cluster name for my Kubernetes cluster that I'm coming up. So I will create a private hosted zone and possibly I will call this as simplilearn.in. So this will be my name of my private hosted zone. In case you already have any other public hosted zones in your name, you can always put a Route 53 hosted zone specific for your domain name. Since I don't have anyone, I'm just going to create a simple private hosted zone. So let me head down to Route 53, click on any of these and you'll get these hosted zones out here. So I'm going to create a hosted zone here. I'm going to create a hosted zone. Click on create hosted zone. This would be simplilearn.in. I want to create a public. No, I don't want a public. I want a private hosted zone, and I'm going to associate my VPC ID for this hosted zone. Since I'm going to try out all my exercises in the Ohio region, I will associate the VPC of the Ohio region for this. All right, so this is the one that is specific to the Ohio region. So I will say this one, I'll say create a hosted zone. Great. Now let me come back to my EC2 box. My EC2 is all powered with whatever it needs in order to go ahead with the installation of my cluster. Only few things that I need to take care of is that, now that I put a name for my cluster, I also have an S3 bucket that I've configured for my cluster. I will have to ensure that I need to put in these two configurations as a part of my cluster building activity. So I will open my bash rc file, and I'm going to export these two variables. If at all you remember well, these two variables are nothing but the cluster name, which is nothing but the the private hosted zone that I created, and the S3 bucket where I'm going to create, or rather I'm going to store my cluster state. So let me copy these two and open up my bash rc file. All right, so I will just add these two and copy these and export them out as my variable. I'm going to save this here. Now let me ensure that this gets picked up. All right, I've got these two that I've configured, and I've also ensured that these environment variables are set. Now let me create a pair of SSH keys. This is to ensure that I can log into the box that I'm going to be provisioning as a part of my cluster. SSH-keygen. I don't want to give any parameters. Let it go to the home directory with the default name and without any passphrase. All right, so I created a bunch of my key pair. Now I'm all set to go ahead and run my kops. Now kops will ensure that this will take some time for the cluster to come up, but this is exactly how I would define my kops command. I already got it copied here. So kops create cluster. The state of the cluster will be stored in this particular variable, which is what I have exported out. The number of node count is 2. Node count is the worker node count. If at all I don't specify, there's a configuration for specifying the master or the control plane as well. If I don't specify that, the default one is 1. So I'm going to create one primary or the master node and two worker nodes. Size of my master, node size of the worker nodes, what are the zones where I want this to be created, and where do I store the cluster information. And okay, I've already added this master count. This is actually not required, but this is the command that I'm going to fire off so that I bring up my cluster. All right, that went off very fast, but this actually did not create a cluster. It is just the definition of a cluster, and that's why this came out very fast. Now that everything looks good with whatever configuration that I specified, now let me go ahead and create the cluster by saying kops update cluster -a. Yes. Now this will take some time, a good 5 to 10 minutes for it to, because this will actually start provisioning the servers. And as I mentioned earlier, based upon my configuration, I'm going to come up with one master server and two nodes, or the worker nodes. All right, so this is the command for me to validate the cluster. And I'm going to try it out first. I'm pretty sure that it will fail because all my servers are not up yet. It is taking some time. The validation, everything failed. But let me try to look at my EC2 instances and see how many servers do I have running as of now. If you see, I had only one server that I had started, which was my cop server, and automatically the other three instances, one is called nodes.simply.in, these two are the nodes, and this is the master node. So these three got automatically provisioned by the kops command that I ran. Alright, so this may take a while for it to get validated, a good 5 to 10 minutes. So what I'll do is I'll pause the video now and I'll come back once the cluster is up and running. It's been a good 8 to 9 minutes since I started my cluster. So let me validate now. Okay, seems good. So there's a master node, minimum 1, max 1, some nodes which are nothing but the slave nodes or the worker nodes. There are two of them, T2 micro, subnet. So my clusters seem to be up and running, and my cluster name is simplilearn.in. So what I would want to do is now let me just log into the master and see if I can run some pods. So let me get back to my installation steps here. The validation cluster is done. So let me log into since my cluster name is simplilearn.in, this is the way to log into my box. So let me get into my box. So if you see here, this is the host name of the machine that I'm currently in. If you see this is nothing but this cop server. This is a server. Now from here, I'm trying to get into the master box. Alright, so if you see, the IP address has changed. I was in a different box. I'm in a different box now. If I see host name, you'll find a different host name. So this is 153, which is nothing but the master node. Yep, it's 153. This is the particular host. So I'm getting into this machine now. So I started the cluster from my COP server here. It ran and brought up 3 nodes. So I'm actually getting into my master node and see if I can run some pods on it. All right, so let me try kubectl get cluster info. Try kubectl get nodes. All right, so there are 3 nodes here, master node and 1 master node and 2 worker nodes. So let me see if I have some pods here. Kubectl get pods. So there's no pod as of now. So what I'll try to do is let me just spin up a very simple pod just to check if my connections is everything is correct or not correct. I have a simple Node.js application that I've built and I've got a container for that. This is already pushed to the Docker Hub registry. It is called Simplilearn Docker Hub, and the image name that I have here is called my node app, and I will use this image to power one of my pods that I will run. So this is the way in which I'm going to launch my pod. Let me show you these commands. Kubectl run, the name for my deployment that I'm going to run, -- image, and this is the image that is going to be powering my container. So this is Simplilearn Docker Hub / my node app -- replicas equal to I want 2 replicas to be running, and the port that I want to expose this particular pod is on 8080. So let me run this. As soon as this is run, it creates something called as a deployment. All right, now let me just say I'm not really interested in the deployment. I'm interested in checking if at all the pods are up and running. So I will say kubectl get pod. All right, so that was pretty fast. So I have 2 pods that are running here. These are 2 replicas because I asked for 2 replicas. These pods are running, so I can run kubectl describe pod pickup. All right, I can pick up any of the pod name and see what is the pod, what is the information does it contain, from what is the image that is pulling, what is the image name ID. This is actually running my pod, which is actually spinning up a container. Great, so far so good. So in Kubernetes, the pods are ephemeral, so they can be there at any time, cannot be at any time. If I need to expose my pod outside, I will have to create a service for my pod. So what I'll do is I'll create a very simple service by exposing this particular deployment. Before that, let me check kubectl get deployment. So there's a deployment that is created. The deployment name is Simplilearn app. So I will expose my deployment Simplilearn app as I'll just expose this. Let me see. All right, I'm not specifying what type and all. I don't want to get into the complications of what are the different types of exposing this service and all that stuff. So if I don't specify anything, it gives me something called a cluster IP. So this is where my pod is actually exposed. So let me just check if at all this pod is up and running. I'll just try a simple curl command. Curl http : this is my cluster IP, and the port is 8080. If at all I hit this, it's actually hitting my application and giving me whatever. I put a simple sys.out kind of a thing where I'm just printing the container ID of whatever pod is serving being served out of. So I'm actually hitting my container and I'm getting this output from the container. So everything looks good. My container is up and running. So let me just go and clean it up. I will say kubectl delete deployment Simplilearn app. This should get rid of all the pods that I created. Kubectl get pod. All right, these pods are interminating things. Let me just check kubectl get services. There's one service. I don't want this service. Let me delete that. Kubectl delete service. I want this. All right, that sounds good. So let me come back to my host, my COP server from where I'm running. So I managed to successfully verify this pod, see if everything is up and running. So what I'll do is I'll just go ahead and complete this demo by going and getting rid of my cluster. So cops delete cluster -es. All right, so this will ensure that it will clean up my complete cluster that I created. So I had 3 or 4 running instances. If you see that, all the 3 are shutting down because the COPS server, which had COPS installed on it, has now got a mandate to go ahead and shut down and clean up the whole instances and all those things that are created as a part of my deployment.
Thank you for joining us on this insightful journey through Kubernetes on the Simplilearn YouTube channel. We hope this tutorial has equipped you with a comprehensive understanding of Kubernetes, from the fundamentals to advanced concepts. If you found this video helpful, don't forget to like, share and subscribe for more enriching tech content. Your feedback matters, so feel free to drop your thoughts in the comment section below. Stay tuned for more exciting tutorials, and until next time, happy learning and happy coding.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.